Hello, everybody. Welcome back to Mathletes Corner. We're here. We're at the last 5 questions. It's the final stretch. So let's get right into problems 21 to 25 from the 2024 AMC8. So problem 21. A group of frogs is living in a tree. A frog turns green when in the shade and turns yellow when in the sun. Initially, the ratio of green to yellow frogs was 3 to 1. Then 3 green frogs moved to the sunny side and 5 yellow frogs moved to the shady side. Now the ratio is 4 to 1. What is the difference between the number of green frogs and the number of yellow frogs now? So we're given that initially the ratio of green frogs to yellow frogs is 3 to 1. So we can say that the number of green frogs is 3x and the number of yellow frogs is x. So when 3 green frogs move to the sunny side and 5 yellow frogs move to the shady side, the number of yellow frogs decreases by 2. And the number of green frogs increases by 2. And now we're given that this ratio is 4 to 1. So now we just have to bash out the algebra. Then we can isolate x, and we get x equals 10. And we go back to the question. The question is asking what is the difference between the number of green frogs and the number of yellow frogs now. So now the number of green frogs, since we know x is 10, the number of green frogs is 32, and the number of yellow frogs is 8. And the difference is 24, and that's E. So problem 22. A roll of tape is 4 inches in diameter and is wrapped around a ring that is 2 inches in diameter. A cross-section of the tape is shown in the figure below. The tape is 0.015 inches thick. If the tape is completely unrolled, approximately how long would it be? Round your answer to the nearest 100 inches. So this question, it's really difficult to actually think about the distance when you unroll it. So what is easier to think about? Well, what's easier to think about is the average distance when we unroll it. So first, we have to think about how many loops do we get when we unroll, and what's the average length of each of those loops. So we know that the whole diameter is 4, the inside diameter is 2, so the thickness here is just 1. So how many rolls do we get? Well, that's whatever we get when we divide 1 by the thickness of the tape. So that's 0.015. Then we can work that out. That's 15 over 1,000. And that's equal to 1,000 over 15, which is approximately 66.67 when you work it out. Now, the average circumference of the circle is when you're halfway from the outside ring to the inside ring. So the diameter of the circle in the middle is just the average of 2 and 4, and that's 3. So the circumference there is 3 pi, and we multiply that by 66.67. This is approximately 10. So multiplying 10 by something from 60 to 70, and then rounding it, gives approximately 600, and that's B. Now, problem 23. Rodrigo has a very large sheet of graph paper. First, he draws a line segment connecting point 0,4 to point 2,0 and colors the 4 cells whose interiors intersect the segment as shown below. Next, Rodrigo draws a line segment connecting points 2,000, 3,000 to point 5,000, 8,000. How many cells will he color this time? Well, the first question that comes to mind is, what is the slope of the line that connects those 2 points? And that's easy to find. That's just 5,000 over 3,000, which is 5 over 3. So instead of thinking of the whole line from one point to another, we can just think about the line that goes from 2,000, 3,000 to 2,003, 3,005. And that line will be repeated 1,000 times. So we can find the answer going between these 2 points and then multiply our answer by 1,000 in the end, which makes a lot of sense since our answer choices all are multiple of hundreds. Now, remember, we're going from this point to this point. So for every 3 units right, if we go 5 units up, then that means for every unit right, we go 5/3 units up. So we go from this point to around there, and from here, we go there, and it'll connect. And this goes through so that's 1, 2, 3, 4, 5, 6, 7. So we go through 7 squares, and then, as we said earlier, we just multiply that by 1,000 to get our answer of C, 7,000. So problem 24. John has made a piece of stained glass art in the shape of 2 mountains as shown in the figure below. One mountain peak is 8 feet high, while another peak is 12 feet high. Each peak forms a 90-degree angle, and the straight sides form 45-degree angles with the ground. The artwork has an area of 183 square feet. The sides of the mountain meet at an intersection point near the center of the artwork, h feet above the ground. What is the value of h? So first in this problem, we notice that we don't have a formula for the area of that shape. But we do have the formula for some familiar shapes, 45, 45, 90 triangles. The problem is our 45, 45, 90 triangles are cut. So what if we put them back? So put this there. Now, what's the area of this 45, 45, 90 triangle? Well, its side length is 8 root 2. So its area can be calculated to be 64 because you multiply the 2 legs, which in this case are equal, and then you divide by 2. Same idea for this. The side lengths are 12 root 2, so the area is 144. But when we add those up, we don't get 183. Why is that? Well, when we add those up, we're double counting this region here. We're counting that twice because it's in both of the triangles. And if we count something twice, when we only count it once, what do we have to do? We have to subtract it out. So here we can write 64 plus 144 plus the area of this triangle. So let's find it, not plus. The area of, minus the area of that triangle. So what is the area of that triangle? Well, here it's h, here we have h, here we have h. So it's 1/2 times the base, which is 2h, times the height, which is h. That comes out to 208 minus h squared. And that is equal to 183. Now we can solve it, and we get h squared equals 25. And since h has to be positive, our answer is 5, which is option B. All right, so problem 25. A small plane has 4 rows of seats with 3 seats in each row. 8 passengers have boarded the plane and are distributed randomly among the seats. A married couple is next to board. What is the probability there will be 2 adjacent seats in the same row for the couple? Well, in this problem, there's no obvious way to count the number of successful possibilities, but it is very simple to calculate the total number of possibilities because there's 12 seats and you need to choose 8 of them for the other 8 passengers. So the denominator of the fraction is just 12 choose 8. For the numerator, as I said before, it's kind of hard to count that. So let's try splitting into cases. So what are our possibilities? Well, the first one is that there's exactly one pair of seats that are adjacent. So something like this, and then this seat's taken, this seat's taken, this seat, this seat, this seat, and then this seat, this seat, and this seat. So something like that. Our second case is that a whole row is empty. So say this whole row is empty. And our third case is that we have 2 pairs of seats in 2 different rows. So let's try to work out these cases and get our final answer. So case 1, as we said before, is 1 pair. Well, how many such pairs are there? Well, there's 8 because in each row we have 2 such pairs of adjacent seats, and we have 4 rows. So there's a total of 8. And the third seat in the row has to be occupied by another passenger because then otherwise we'll have a whole row empty, which will count in the next case. So with that occupied, we have 9 seats for 7 passengers, and the 2 empty seats cannot be next to each other. So we have 9 choose 7, but we can't have the empty seats be one of the 6 remaining pairs of adjacent seats. And evaluating this comes out to 8, and 9 choose 7 is the same as 9 choose 2, which is just 36. Subtracting 6 gives 30, and that comes out to 240. Now, case 2 is that we have a whole row empty. For this, there's 4 ways to choose which row, and then out of the remaining 9 seats, 8 of them are taken, so there's 36 remaining. Now, for our third case, we have 2 different pairs of seats in 2 different rows. Say we chose the top left pair. Now, we can't choose the pair in the same row, but we can choose any of the other 6 pairs. So, for each pair, so that's 8, there's 6 ways to choose the other pair. And we double counted everything since we could have chosen anything in reverse order. And now that we've chosen 2 pairs of empty seats, there's only one way to place the other 8 passengers since there's only 8 remaining seats. So that comes out to 24. Now, 24 plus 36 plus 240, that comes out to 300. Now, 12 choose 8 comes out to 495. The numerator and the denominator are both divisible by 15, giving us a final answer of 20 over 33. And we're done. Thank you for watching this video. Good luck to everybody taking the AMC8. Don't forget to hit that like and subscribe button, and we'll see you next time here at Mathlete's Corner.